So very good morning. Today's topic is what? Elements. Elements means resistor, inductor and what? Capacitor. So if you have any doubts then yes you can ask. कोई भी आपको डाउट है प्रीवियस क्लास में से तो आप पूछ सकते हैं. तो in previous class we have discussed about what basics of networks, syllabus, textbook or basic idea about what current, charge, how to find the integration, how to calculate the charge, how to calculate the current and साथ में हम लोगों ने निकाला था क्या? स्लोप ऑफ द कर्व. कैसे स्लोप्स निकालते हैं, हाउ टू फाइंड द इंटरसेप्शन. ओके, कहीं भी कोई डाउट है? So this is a network theory lecture 2, classification of the elements means resistor, inductor and what? Capacitor. Okay. Then first of all, for new students, that is my introduction. Myself Sanjay Rathi. This is my teaching experience, 24 years through offline classes and online classes. ओके जितने भी आप इंस्टीट्यूट्स की बुक्स वगैरह पढ़ते हैं वो सब जगह मैंने ऑलमोस्ट सभी प्लेटफॉर्म्स पर मैंने अपनी क्लासेस दी हैं. शुरू के स्टार्टिंग पिलर से जिन्होंने एक करिकुलम सेट किया था कि किस सब्जेक्ट में कितनी डेप्थ में आपको पढ़ाना है. ओके तो नंबर ऑफ सब्जेक्ट्स है मेरे. मैं आप लोगों के साथ एक एक करके सब्जेक्ट लेता रहूँगा. जैसे अभी नेटवर्क थ्योरी, देन ईडीसी, देन एनालॉग, देन माइक्रोवेव, माइक्रो प्रोसेसर एंड बेसिक्स अबाउट व्हाट एडवांस इलेक्ट्रॉनिक्स. दीज आर माय subject. Okay sir, answer for assignment questions मिलेगा. Wait for that. Okay so this is my experience and I have qualified and selected for engineering services exam that is conducted by UPSC. तो अभी किसी का है? अभी प्री एग्जाम हुआ है फॉर इंजीनियरिंग सर्विसेज. यहाँ किसी ने दिया था प्री एग्जाम? You have attempted engineering services pre on I think 8th of June. ओके उसका तो रिजल्ट भी आ गया वैसे प्री का और अब मेंस की तैयारी स्टार्ट हो रही है. तो यू कैन टारगेट फॉर व्हाट नेक्स्ट ईयर इन 2026 फॉर इंजीनियरिंग सर्विसेज एग्जाम आल्सो. अभी लेकिन फोकस रखो इसरो पर. देन these are my subject guys. Circuit elements. First of all, one minute. Okay. Yesterday we have discussed what charge, current, power, okay, and how to calculate the slope of the line. Then area, how to find the area. Usually there is one question. Then we will start with what? Active and passive elements. Now tell me, this is the question. Find the equation of current IT for the given graph between IT and T. What are the equation for this line, that line, this line, that line? Also find the charge Q at T equal to 1 second, 4 second and what? 5 second. Okay, so yesterday we have solved this type of questions. So tell me what will be the answer. Okay, first this is the portion, second portion, third portion and fourth portion. So for first portion, what is the slope? M1, this is M2. What is the slope for M3 and what is the slope for M4? And what are the interception for this? For what is the C1 for this? Because once you have the value of the slope and interception, then you can directly find what equation? Relation between IT and T. This is the T in seconds, okay? And IT is in ampere. What is the interception for this? What is the interception for this and what is the interception for this portion? And you can use the same technique just for quick revision. क्या किया है आपने देखें जरा और आंसर लिखिए भाई सब कमेंट्स में. Brief on ESE and IS exam once after the class. Okay. First of all, already I have uploaded one session on YouTube. What are the basic pay, how to calculate the payment, and what about the pay matrix according to 7th pay commission. So you can go through it, everyone, for engineering services exam or what other competitive class 1 ऑफिसर जो है ना, उसके लिए आप देख सकते हो. फिर मैं आपको बताऊंगा कि कैसे आप इंजीनियरिंग सर्विसेज और कैसे होते हैं क्लास 1 ऑफिसर, क्या क्या अथॉरिटी पावर सब कुछ है भाई. तो बताइए जरा इसका फर्स्ट लाइन, सेकंड, थर्ड एंड व्हाट फोर्थ वन. 1 2 3 4. हेलो सर, इज दिस कोर्स इज सफिशिएंट फॉर ESE prelims paper 2? Yes, that course is what sufficient, but you have to solve what PYQs, previous year questions. Okay. फिर लेकिन ना start, if you want to clear engineering services, then what you have to start preparation for what mains also, how to write the answer. एक कॉम्प्रेहेंसिव कोर्स है ना, दैट इज अ कॉम्प्रेहेंसिव कोर्स. अगर आपने कोर्स कंप्लीट किया, आप PS भी निकालोगे और भी जितने भी कॉम्पिटिटिव एग्जाम्स है सब निकलेंगे. ओके, टेल मी व्हाट इज द आंसर. किसी का भी जवाब नहीं आया अभी. व्हाट इज द स्लोप ऑफ द फर्स्ट लाइन? इज इट ऑडिबल? एवरीथिंग इज फाइन? ओके ओके, चलिए. 3. नाउ फर्स्ट ऑफ ऑल न्यू स्टूडेंट्स सब फोकस करो जरा. देखिए, फर्स्ट इन 2 steps, very easy. In 2 step it is increased by what? 6. So in 1 step it will increase by what? 3. So that is the slope M1. Very simple. In a 2 step it is increased by the 6. So in 1 step it will increase by 6 by 2 and it is a positive slope 3. And what is the interception? 0. Where is the interception with the y-axis? Here it is 0. Okay, once you have the interception, and then you can directly write the equation I is equal to mx mt plus c, because on x-axis it is time, so it is the I1. So what is the I1 for this first portion? From 0 to 2 you can write I is equal to slope 3t only, and this is applicable for 0 is less than equal to what? 2. So this is the first one. So we can define the current. क्या लिखा है? Find the equation of the current for the given graph between IT and T. So this is the first, I is equal to 3t. Second, what is the slope of this portion? In 1 step, this is the 1 step from 2 to 3, it is decreasing, means negative slope, or it is decreased from 6 to 4. So 6 to 4 means what is the change? Minus 2. Minus 2 divided by 1. So what is the slope here for second? Minus 2 divided by 1, that is the minus 2. In 1 step it is decreased by 2. And what is the interception here? तो क्या लिखा है आपने interception? तो 3 minus 2. Okay. Okay, what is the interception here? Watch this. It is decreased by 2 here. Try to understand. We have the 2 way to find the interception. First, what is the decreasing? 2, right? And now move backside. When we are moving backside from 3 to 2, it is increased by the 2. So from this is 4, so this is 6. So again from 2 to 1 it is increased by 2, 8. Again from 1 to 0 it is increased by 2. So it will cut at what? 10. So what is the interception here? 10. Is it clear? Any doubt here? From 4 to 6 it is increased by 2. From 2 to 1 it is increased by 2. Right? From 3 to 2, 4 to 6. 2 to 1, 6 to 8. 1 to 0, 8 to 10. And that's why the interception is 10. And what is the equation then? I is equal to slope minus 2t plus 10. Minus 2t plus 10. ओके एंड दिस इज द इक्वेशन। तो ये थोड़ा ध्यान दीजिएगा, यहां पर आता है ये स्लोप एंड सो ऑन। देन इज इट विजिबल, एवरीथिंग इज फाइन? ओके, देन वॉच दिस, और अदरवाइज यू कैन फाइंड the slope is in one step it is decreased by 2, so what is the slope here? -2. And then you can write equation I is equal to -2t plus c. Now you can find the interception here exactly at 3. What is the value? Exactly at 3, when the time is 3, what is the value? 4. So you can put here at t equal to 3, I is equal to 4. 4 is equal to -2 into 3 plus c. So what is the value of the c? 4 plus 6, that is equal to 10, and then you can write the equation -2t plus 10. We are getting the same answer. Same answer. Okay, now next one. Now watch this. What is the slope for this one? This portion. So in a one step it is increased by from 3 to 4, it is increased from 4 to 5, that's why the slope is 1. Slope is 1, positive slope. Now you can find the interception with the y-axis. This is one step, it is decreased from 5 to 4, then 3 to 2, one step, this is 5, this is 4. So what is the value at this point? 3. What is the value at this point? 2. What is the value at this point? 1. I think it is clear to you. Decrease 1 1 1 1, and what is the 1? So interception is 1. Equation become for this portion 3 to 4, slope is 1, that is the equation. यहां पर आया time 2 to 3. This is the time, this is the time, -2t plus 10, -2t plus 10, or here this is t plus 1. Okay, last one, last slope. Watch this, this portion 6 to 4 in a 2 steps, this is the 2 steps, it is decreased from 5 to 0. So what is the change? Total change is what? 5. So in one step what is the change? 5 by 2 minus 2.5. The slope for this portion is -2.5. Now in every step it is increased by what? 2.5. So this is 5. How many steps? 1 2 3 4. 1 2 3 4. 4 into 2.5, it is increased by what? 10. So 5 plus 10, what is the value? 15. This interception is at what? 15. Is it clear, guys? 2.5, 1 2 3 4. 4 into 2.5, 10. 5 plus 10, this is the 15. So what is the equation here? I is equal to -2.5t plus 15, and that is 4 is less than t is less than what? 6. 4 is less than t is less than what? 6. Okay, so ये हो गया -2.5. So in this way we can find the slopes and so on. So or you can verify it exactly at 6. What is the value here? 0. So you can verify I is equal to exactly at 6 -2.5 into 6 plus 15. So this is not 15 minus 15, that is 0. Verify this is correct. This equation is correct. So this is the way. No need to calculate. Directly from the graph you can say what is the slope, what is the line equation and so on. Interception यही निकाल लोगे, है ना? ठीक है ना? स्टेप्स पीछे आगे आओ, लेफ्ट मूव करो, राइट मूव करो, और ये देख लीजिए आप कैलकुलेशन. ये होता है क्विक जब आप क्वेश्चन सॉल्व करोगे, अराउंड 8 to 10 क्वेश्चंस on one topic, automatically you will get the command over that. तो आपको थोड़े क्वेश्चन सॉल्व करने पड़ेंगे, प्रीवियस ईयर क्वेश्चन सॉल्व कीजिए, प्रैक्टिस करना पड़ेगा, राइट। तो प्रैक्टिस से अपने आप बन जाएगा। तो बहुत सही आपने जवाब दिया था, 3 -2 1 एंड -5/2, बिल्कुल सही। चलिए अब एक बार इक्वेशन आ गई तो आपको दूसरा क्वेश्चन क्या पूछा, फाइंड द चार्ज एट 1 सेकेंड, 4 सेकेंड एंड 5 सेकेंड। तो देखो चार्ज अगर आपको फाइंड करना है तो आपको इक्वेशन या तो इंटीग्रेट करो या फिर आप डायरेक्ट एरिया निकालो। यू कैन फाइंड द एरिया एट 1 सेकेंड, 4 सेकेंड एंड 5 सेकेंड। तो जैसे आपको दिया हुआ है एरिया 1 सेकेंड पर यहां ये वैल्यू, ओके। अब जैसे इसकी स्लोप आपको दिख नहीं रहा है एग्जैक्टली एट 1 सेकेंड, आपको यहां का एरिया निकालना है, तो ये कट किस पे कर रहा है, तो in a 2 step it is increased by what 6, so in a 1 step it is increased by what 3, not 4. This value is 3. So what is the area of the curve, half of base into height? So first charge up to 1 second, half of base, what is the base, 1 into height is not 4, it is 3, 1.5 coulomb, 1.5 coulomb up to this point. From this point to this point, 1 up to 1 second. So exactly at 1 what is the value, what is the height here? So at 2 it is 6, that's why at 1 it is 3. Okay, now second question, up to 4 second what is the charge, 4 second. Now 4 second already we have this area, up to 4 second means up to this point. We have to find the area A2, area A3, area A4. So A1 already we have 1.5, A2, this is a trapezoid, so what is the value, 3, and what is the value, 6, so height 3 and 6, and what is the perpendicular distance, 1 here, this is 1. So you can find the area A2, half of opposite side, sum of opposite side 3 and 6 to 1, this will become 4.5 coulomb. This is the 4.3 plus 6, 9, 9/2, this area A2. A3, this is 6, this is 4, this is the perpendicular distance is 1, half of this is 6, this is 4, 5. Please check my calculation, this is 6, this is 4. Now last area, this is 4, that is 5, this height is 4, that is 5, and this is 1. Four plus 5, 4.5 coulomb, and add addition, 4.5 plus 1.5, that is 6, 6 plus 5 11, 11 plus 4.5 15.5 coulomb. Okay, तो यहां up to this point, up to 4 second, and then up to 5 second, up to 5 second means add the area A5. So what is the A5, this is the one step. Okay, now we have this portion, this is the 5 actually. What about this, so what is the value at this point, tell me, what is the value at this point directly, if suppose you have to calculate, what is the value at this point, बताओ जरा कितनी वैल्यू है। तो इसी से एरिया निकलेगा, this plus this into distance between these two, half of multiplied and so on. तो बताइए वहां पे what is the value at this point. Already we have the idea, slope, what is the slope of this line, 2.5, बिल्कुल सही. This is in a 2 step it is decreased by 5, so in a 1 step it is decreased by 2.5, so 5 minus 2.5, this is the 2.5. So A5 is equal to half of 5 plus 2.5 into 1. Okay, that is nothing but 7.5 divided by 2, that is 3.75. 3.75. So okay, up to 1 second only area A1, this is area A1. up to 2 second A1 plus A2, up to 3 second A1 plus A2 plus A3, up to 4 second A1 plus A2 plus A3 plus A4, up to 5 A1 plus A2 plus A3 plus A4 plus A5 and so on. Up to this is what is the area of this triangle. So triangle means half of base into height. What is the height? 2.5. What is the base? 5. So the area for this is half of base into height. That is the 1.25. This is A6. Crystal clear? No doubt? How is A3 and A4 calculated? We should calculate the triangle and rectangle. No. This is the trapezoidal. Trapezoidal means, okay. Don't worry. Just watch this. Now focus on this. A2 है ना? A2. This is a right. This is a triangle. So all first of all height. What is the height here? 3. What is the height here? 6. And then what is the gap here? 1. Okay. So you can yes area. Rectangle. What is the area of the rectangle? This is the A1, this is the A2. So you can say area of the rectangle is 1 into this side into this side. This is the perpendicular distance, this is the A. This is A. So A into A, this is A. Okay. So ये हो गया 1 into A and this is A1. What is the A2? Half of base. What is the base? Again 1. This is the perpendicular distance into what? Height. So this is 3. This is 6. So what is the height? 3. 1 into A, that is nothing but 3. This is 3. 3 by 2. So 1.5. This is 3. To total area is what? 4.5. Yes, we are getting the answer 4.5. Clear? तो वन ये है ट्रायंगल वो निकालिए ना. दिस इज द ट्रेपेजॉइडल. फर्स्ट स्क्वायर सॉरी रेक्टेंगल एंड देन ट्रायंगल. और डायरेक्टली दिस इज द ट्रेपेजॉइड. ट्रेपेजॉइड मींस give me 1 minute. हाँ, this one. Suppose it is given. So this is A, this is B, and what is this? Perpendicular distance H. So what is the area of this? Half of summation of the opposite side A plus B, and what is the perpendicular distance between these two? H. So this is the area. So this is the trapezoid. Opposite side this plus that, and this is the one. So we are getting the same answer. It is clear now? Okay. याद रखो ना ये टाइम, we have to save the time. Quick calculation is required. Okay then, next. अब कोई डाउट नहीं है? कोई फर्दर एनी डाउट? चलिए स्टार्ट करते हैं आज का टॉपिक. वो आंसर मैं बताऊंगा एट द लास्ट, एट द एंड आई विल गिव यू द आंसर. बहुत ही इंपॉर्टेंट टॉपिक है आज का हमारा, सर्किट एलिमेंट्स. सर्किट एलिमेंट्स. An element is the basic building block of circuits. Yes, we have the idea. We have the circuit elements, right? What? Resistor, inductor, capacitor, battery. So some are the passive elements, some are the active elements, right? Or we can distribute on the basis of what? Passive, active, linear, non-linear, bilateral, unilateral, For example, diode. Diode is also element. This is the diode. Okay. Linear elements, non-linear elements. Sometimes that capacitor is linear, sometimes this capacitor is non-linear. Behavior is non-linear. What about this device? This device is non-linear. Okay. And then lumped parameter, distributed parameters. For example, these all are what lumped parameters, but in transmission line we are representing like this. Transmission line. So this is the equivalent circuit of the transmission line. These all are what distributed parameters. So one by one we are going to classify it. So element is the basic building block of a circuit. Circuit analysis is the process of determining the voltage across or the current through the elements of the circuit. So what we are doing actually, circuit analysis means what? We are calculating the current, we are calculating the voltage across each element R1, R2, R3, or voltage across the capacitor C1, C2, C3. Then we are finding the energy, half of CV square, and so on. So basically we want to calculate the current and we want to calculate the voltage. So we are using the different types of methods, like first of all KCL, Kirchhoff's current law, KVL, Kirchhoff's voltage law, mesh analysis, nodal analysis, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, superposition theorem, Millman's theorem, Telegan's theorem. Actually what we are doing, we are calculating the current, we are calculating the voltage, or at the end we are calculating the power, right? तो ये सब वही है. There are two types of elements found in the electrical circuit: passive elements and what active elements. That is the basic criteria: passive elements and what active elements. Okay. Then what are the active and what is the difference between the active and passive elements? For example, here resistor, inductor and capacitor, they are not capable to produce what their own energy. They are not energy sources. Okay, but what about this battery? That battery can produce what its own energy. So this is the active element, but these all are what passive elements. R, L and C. They are getting the energy from this source. No doubt, inductor can store the energy, capacitor can store the energy. Okay, जैसे इन्वर्टर में होता है ना घर में, we are storing the energy in what inverter? We are storing the energy in our UPS, right? Uninterrupted power supply. So, but actually we are storing, but that is not the source. That is not the source. So what is the difference between the active and passive elements? It is capable of generating energy. It is not capable of generating energy. Deliver power to the circuit. Absorb power from the circuit. Control the flow of current. Yes, it will control the flow of current. Change the polarity of the diode. Watch this. How it will control the flow of current. This is the polarity of the battery. This is the 5 volt. This is the 1 ohm. So there is a current 5 ampere from left to right. Suppose you are going to change the polarity. Resistor will remain same. Just change the polarity. 5, 1. What is the direction of the current? Opposite direction, 5 ampere from right to left. Just by changing the polarity you can change the direction. Means the flow of current is controlled by battery or source. Just change the polarity, you can change the direction of current. Then control the flow of current, capable to provide the power gain. Yes, actually what is the active element? For example, this is a very important point now. Capable to provide the power gain. For example, just I am asking, give me the answer. Everyone give me the answer. This is the transformer. Okay, we are having the turn ratio N1 is to N2. This is 1 is to 10. Here the voltage is V1, here the voltage is V2, current is I1, current is that I2. Then according to turn ratio of the transformer, V2 by V1 is equal to what? N2 by N1. This is the 10 by 1, तो व्हाट इज द V2 इज इक्वल टू 10 टाइम्स ऑफ V1, 10 टाइम्स ऑफ V1. Yes. तो tell me guys, it is a active element or passive element? Because the active element will provide the power. So tell me, is it an active element or passive element? Transformer is amplifying the voltage, yes or no? Amplification, yes or no? Yes. So it is active element. Yes or no? Everyone please participate. Please participate. Active element, yes or no? बोलिए यस नो. वाई और एनी तो लिखना है. अभी भी यार इतने सारे लोग अटेम्प्ट करते हैं. डरते काहे को आप पोल से? गलती तो होगा, मैं हूं ना. शाहरुख खान वाला मैं हूं ना नहीं हूं भाई. आई एम हियर. ओके. और बेझिझक अभी देखो, एक तो ना मेरे को पहली बात आपको बता दूं, ये तो ऑनलाइन क्लासेस है. ऑफलाइन क्लासेस में भी आज भी मुझे कभी ना किसी भी बच्चे को मैंने डांटा नहीं है. मतलब पर्टिकुलर एक को पॉइंट आउट करके मैंने आज तक नहीं डांटा. आज मुझे 25 ईयर्स हो गया, अराउंड 25 ईयर्स इन टीचिंग. एक को भी मैंने डांटा नहीं है. हाँ, भरी क्लास में भले सबको नॉर्मल तरीके से डांटा कि भाई चुप हो जाओ यार, हल्ला मत करो. और मेरी क्लास में बिल्कुल हल्ला भी नहीं होता था. पिन ड्रॉप साइलेंस और हंसी मजाक सब चलता है बस. राइट. लेकिन डाउट पूछना है. क्यों ऐसा माहौल है? क्योंकि वो डाउट पूछ सके, वो अपना ना क्वेरीज जनरेट कर सके कि डाउट पूछ सके. अदरवाइज इंटरेस्ट ही नहीं आएगा पढ़ाई में. तो इसीलिए मैंने एकदम बिंदास किया हुआ था. जो पूछना है पूछो, जैसा पूछा. जितना आएगा मुझे उतना बताऊंगा, नहीं आएगा तो ब्लफ नहीं करूंगा. ये नेवर ब्लफ. राइट. वो मुझे नहीं आएगा ना तो मैं एक्सेप्ट कर लेता हूं, यार सॉरी भाई ये तो आता ही नहीं, और वैसे भी है, और या फिर कोर्स में ही नहीं है. आउट ऑफ सिलेबस मत जाओ, जरूरत नहीं है उसकी. और अगर लगता है कि यार ये रिलेवेंट है लेकिन मुझे नहीं आता, तो यस, ब्लफ मत करो. ब्लफ करने से क्या गलत इंफॉर्मेशन चली जाती है, तो वो नहीं करना है आपको. और उसको बोलना है ना 2 दिन लगेगा यार, रुक जाओ, गिव मी 1 डे और 2 days, आई विल कलेक्ट द इंफॉर्मेशन एंड देन आई विल इन्फॉर्म यू अबाउट दैट पर्टिकुलर क्वेश्चन. तो आप भी कोई भी डाउट्स पूछो, अच्छे डाउट्स पूछो, और थोड़ा सा पार्टिसिपेट करो, एक्टिव रहना. जितने भी लोग अटेम्प्ट कर रहे हो यहाँ पे एक्टिव रहो थोड़ा, कि हाँ ये भाई थोड़ा लगना चाहिए एनर्जी सुबह सुबह मॉर्निंग में. और I have choose this class now morning 6:30 to 8:30. तो प्लीज ट्राई टू अटेंड रेगुलर क्लासेस इन मॉर्निंग सेशन. एकदम ज्यादा एनर्जी के साथ आप अटेम्प्ट कर सकते हो. अब देखो जरा, ये ट्रांसफॉर्मर आपने बोला है एक्टिव एलिमेंट है. राइट. आंसर इज व्हाट? नो. आंसर इज नो. इट इज नॉट एन एक्टिव एलिमेंट. व्हाई? देखो ये ट्रांसफॉर्मर है, ये 1:10 का रेशियो है. तो व्हाट इज द वोल्टेज हियर? V1. व्हाट इज द वोल्टेज हियर? 10 टाइम्स ऑफ V1. But what about the current? I2 by I1 is equal to what? N1 by N2, opposite ratio, 1 by 10. So I2 is I1 by 10. So voltage increases, current decreases. What about the product? Product of the V1 I1 at this end. So what is the V1? देखो, is equal to what? V2 I2. You can verify what is the V2. 10 times of V1. What is the I2? I1 by 10, and you will get the V1 I1. You can verify it. V2 I2 is equal to 10 V1 I1. So power at this point and power at this point remain same. If the power on the left and power on the right side remains same, means it is not an active element. Power होना चाहिए, power. There should be increase in what? Power. So for example, if suppose you are using any amplifier, for example you are going to use any amplifier, any BJT or what operational amplifier or what FET. So if it is amplifier, definitely watch this. We are giving the input, we are getting the output. For example, at this point, voltage is V1, current is I1, power is P1. At this point, voltage is V2, current is I2, power is what? P2. Okay, try to understand. How many number of cases V1, I1, P1 or at the output side V2, I2, P2? First case, V2 greater than V1, I2 greater than I1, okay, P2 greater than P1. Okay, voltage is greater than, current is greater than, output voltage is greater, output current is greater, and power is greater, because power is nothing but product of V1 and I1, V and I. So power is also greater. So that's why it is an amplifier. Second case, it may possible voltage is greater than V1, but current is less than I1. It may possible. Output current is less than input current. But at the end, power is greater than P1. Because the power is what? V2 I2 product. And P1 is equal to V1 I1. Product is greater. And that's why it is again amplifier. Third case. V2 is less than V1. Okay, no problem. I2 is greater than I1. And the power is greater than what? P1. Again power. Product is higher. V2 I2 is greater than what? V1 I1. If the product is higher, again it is an amplifier. Are you getting my point? In three cases, this may possible, this may possible, this may possible, it is amplifier. But if the P2 is less than P1, it is not an amplifier. So always remember what is the meaning of the amplification? First basic criteria. Power at the output should be greater than power at the input. Then we can say signal will amplify. Okay? पावर आना चाहिए ना, पावर ही नहीं आया तो वोल्टेज करंट तो बस सिग्नल है. सो प्रोडक्ट निकालना है हमको, एंड जस्ट टू कैलकुलेट द पावर मल्टीप्लाई वोल्टेज एंड करंट. तो जैसे फॉर एग्जांपल बीजेटी इज एन एम्पलीफायर, राइट? ऑपरेशनल एम्पलीफायर इज एन एम्पलीफायर, मॉसफेट इज एन एम्पलीफायर. और देखना बहुत ही इंटरेस्टिंग है, फर्स्ट केस, सेकेंड केस, third case. Tell me, Ajay, you have basic idea about the BJT? Yes or no? Basic idea about the BJT? Everyone, all are engineers here. You have heard about the common emitter, common collector and common base. Heard about the common emitter, common collector, common base? Yes, three cases. First, second, third. Common emitter, common collector, common base. In FET, we have the three: common source, common drain, common gate. Yes, again three cases. 1, 2, 3. All are amplifier. In every case, output power is greater than input power. But there is a variation in what? Voltage and current. In one case, both are high. In one case, voltage is high, current is low. In other case, current is high, voltage is low. So there are three configurations: common emitter, common collector, and common base. Similarly, in operational amplifier, we have. Similarly, in MOSFET we have. Okay, so these all are what? Active elements, because output power is greater than input power. But transformer is not an active element, it is a passive element. Passive element. इंटरव्यू का क्वेश्चन है, इसरो इंटरव्यू में पूछेगा. इंटरव्यू वन क्वेश्चन प्रिपेयर्ड. इंटरव्यू क्वेश्चन. ओके, now, so please guys remember, each and every topic is important, each and every word is important. It may be for written examination, it may be for what? Interview. Okay, और वो भी नहीं है तो आगे लाइफ में यूज होगा नॉलेज आपका. Then next point, capable to provide the power gain, incapable to provide the power gain. Then generators, batteries, and operational amplifier, BJT, MOSFET, these all are what? Active elements. What are the passive elements? Resistor, capacitor, and inductors are the passive elements. Resistor, inductor, and capacitor are the passive elements. Okay, so I think all the 4 points, 5 points are clear to you. Done. अब आते हैं सेकेंड जो क्लासिफिकेशन है, दैट इज व्हाट बायलैटरल एंड यूनिलैटरल एलिमेंट्स. Bilateral and what unilateral elements. Bilateral means for example, this is the value, this is an element, for example, I am giving here the 10 volt and I am getting the current 1 ampere in this direction from left to right. Now change the polarity, same element, change the polarity of the battery and measure the current, you will get the same answer, 1 ampere. Okay, so that is what bilateral, from left to right, right to right, right to left, the characteristics will remain same. Characteristics will remain same. So bilateral. For example, in the theorems we will learn about what reciprocity theorem. So that is what for bilateral network we are verifying the reciprocity theorem. So this type of elements are called bilateral element. Okay, resistor is a bilateral, inductor is a bilateral. अगर लीनियर रजिस्टर ले रहे हैं तो ये देखिए, the property of circuit does not change with the change of the direction of supply voltage or what current. The property of the circuit change with the change of the direction of the supply voltage or what current. The voltage current relation is same for current flowing in either direction. The relation will remain same. Unilateral element has different relation between the voltage and current for the two possible direction. High conductivity material, for example, copper bar, aluminum bar, silicon diodes and metal rectifiers. Okay, for example, it is a copper bar. So it is, yes, it is a copper bar means what? Resistor. High conductivity, just it is represented by a resistor. From left to right, right to left remain, characteristics will remain same. But what about the diode? What about the diode? Now it is forward bias, then it will allow the current. It is reverse bias, it will not allow the current, or it will allow the current, just a very small current, reverse saturation current. So it has the different characteristics. So watch this. This is the voltage, this is the current. What about the characteristics of the diode? Like this. Here the voltage is positive, here the voltage is negative. Characteristics are entirely different, and that's why it is a unilateral device. It is a unilateral device. So what is the bilateral device? Bilateral, for characteristics for bilateral, same characteristics we are getting. This is the first, always remember new students, this is called the first quadrant. Here the voltage and current both are positive. This is called the second quadrant. Here voltage is negative, current is positive. This is called third quadrant. Here both are negative, current is negative, voltage is negative. And this is called the fourth quadrant. Here voltage is positive but the current is negative. So we are changing the polarity of the voltage, the current will change the direction, and that's why it is, and that it has the same characteristics. Then it is called what? Bilateral element. Okay, अभी और भी compare करेंगे bilateral में. Then, so this is a unilateral, diode is a unilateral device. Copper bar or high resistor are bilateral device, guys. Next is what? linear element and non-linear element. Linear and what? Non-linear elements, guys. So linear means the element which will follow the Ohm's law. Okay, so Ohm's law means I is proportional to what? V, or I is equal to what? V by R. एकदम बेसिक डेफिनेशन ओम्स लॉ जाना है ना, तो 12th की क्लास में से पढ़ लो, व्हाट इज द ओम्स लॉ एंड सो ऑन. लेकिन यहाँ पे हम लोग बस देख रहे हैं कि I is equal to V by R. तो एलिमेंट विच विल बी अ लीनियर रिलेशनशिप बिटवीन वोल्टेज एंड करंट, linear relationship between voltage and current, if that R should be what? Constant. Then I is proportional to V, R is what? Constant. The slope is constant. Then it is called a linear element. That will not have the linear relationship. For example, resistor, capacitor, inductor. Here the semiconductor devices, transformer, iron core inductor follow the Ohm's law, does not follow the Ohm's law. So linear and non-linear element. If the circuit is linear, then we can apply the superposition theorem, guys. So in a superposition theorem, we will get the idea how we can prove that particular circuit is linear or non-linear. ये clear है? Is there is any doubt? चलिए ग्राफ देखते हैं लीनियर एंड नॉन लीनियर का. देखिए, this is voltage, this is current. What about the slope of this line? R 1 by, this is the I is equal to what? V by R. So I is equal to mx plus c. So this is the mx plus c. So what is the m? M is 1 by R. X is what? V. What is the interception? It should be 0. So this is a linear element. This is a linear. We are changing the value of V, I will change, guys. So linear relationship. Suppose this curve starts from this point. No doubt the slope is constant, but interception is not 0. Right, interception is not 0. So that equation will become I is equal to what? mv plus c. This is a non-linear. This is a non-linear. Why? Because when the voltage is 0, we are getting some current. When the voltage is 0, we are getting some current, and that's why it is a non-linear, guys. Remember. So ये है non-linear, but this is what? Linear. Now this type of questions we are getting in ISRO examination, remember. Then this type of curve. There is a change in slope. So it is a non-linear, guys. It is also a non-linear. This is non-linear. Diode characteristics is non-linear. So this is a non-linear because there is a change in the slope. Slope is not constant. This is also non-linear. But if I want to say what is this? Unilateral or bilateral? So it is a non-linear. Unilateral. Unilateral means in a first quadrant and in third quadrant characteristics are not same, and that's why it is non-linear unilateral. It is a non-linear, no problem, there is a different slopes, non-linear, but it is bilateral. Bilateral. Why? Because in first quadrant and third quadrant characteristics are same. Characteristics are same, that's why it is called what? Bilateral. This is the unilateral, that is the bilateral. Okay, both are non-linear. What about this? It is a linear. and what unilateral, bilateral. So in this way we can verify it. Keep characteristics should remain same. Characteristics should remain same. Okay. Then, or we will solve more questions on that. To watch this carefully. The first question, I think not is clear. Active, passive, bilateral, unilateral, linear, non-linear. Diode characteristics is non-linear. Diode characteristics is what? Non-linear, guys. I think PDFs for previous class PDF available. You have downloaded the PDF? Tell me yes or no. You have downloaded the PDF? Yes, na? Available. Okay. Now, अब देखते हैं जरा. Next is what lumped parameter and distributed parameters. So this is a very important for ISRO because we have to deal with what high frequency elements, high frequency devices, like high frequency components, like what in microwave. Already I have taken the 2 sessions on microwave on just YouTube. You have joined the paid classes, so I will take the complete microwave in a very detailed manner. Okay, about what microwave components, E plane T, H plane T, or magnetron. These are the amplifiers. 2 cavity klystron, reflex klystron, TWT, BWO. So I am going to cover all the topics. अब यहाँ पर देखो, this is a lumped parameters and distributed parameters. Lumped parameters and distributed parameters means, now focus on this. Then this is the wavelength. This is called wavelength. That is the path traveled during one cycle. This is omega t. So what is the change in the phase? This is pi and this is what 2 pi. Or what is the time period up to this point? T. So in one time period, what is the total phase change? 2 pi. And what is the path traveled? Lambda. And lambda is called what? Wavelength. Lambda is nothing but wavelength. Okay, what is the phase change? 2 pi during one cycle. Phase change is what? 2 pi. What is the rate of change of the phase? Omega is equal to 2 pi by t, because t is the time period, 1 by f time period. It is in second, and f is called the frequency. So omega is equal to what? 2 pi f. F is called what? Frequency. Number of cycle per unit time, or the unit of the omega is radian per second. Radian per second, or this is what? Hertz, and this is the time period is in second. So this is the case. In one cycle, what is the path traveled by the wave? Lambda. What is the total phase change? 2 pi. So in half cycle, what is the path traveled? Lambda by 2. What is the phase change? Pi. Okay. Now this is a distribution. In microwave, again we will enter into the depth of this. Now watch this signal. Okay. Now this is the signal, first one, and this is the signal. Now guys, there are two signals, first one and second one. For the first one, time period is T1, time period is T2. Frequency is F1, frequency is F2. Omega 1, omega 2. Lambda 1, lambda 2, wavelength. Now tell me, what about the time period? In which case the time period is low and time period is high. So when I am talking about the time period means what is the time taken by the wave to complete the one cycle. This is the one cycle. So this is the time period from this point to this point. This is the T1. Or here the time period from one cycle. This is the one cycle. This is the time period T2. So T1 is very less. T1 is very greater than what T2. T2. For first time period is what, very high. Right, T1 is greater, yes. Then what about the frequency? And because of this reason we can say that in second case the frequency is very greater than what, F1. Time period is low, frequency is very high, number of cycles. Okay, now in one cycle, in one T completed one cycle, or in one T how many cycles? More than that. Number of cycle is very high, that frequency is very high. So frequency is high means what is the rate of change of the phase? Very high. And when the, remember guys, velocity is equal to, velocity of wave is equal to F into lambda. For example, velocity of light C is equal to F into lambda. So what is the lambda? V by F. Frequency is high, definitely lambda is low. So this is the lambda in one cycle. So in one cycle it is only lambda, very small. So lambda 2 is very less than what, lambda 1. Lambda 2 is what, very less than what, lambda 1. Now remember guys, if the wavelength is very small, for example, we are dealing with the two types of frequency. Just watch this. Okay, give me 1 minute. You are dealing with what? Frequency. In a circuit theory, we are dealing with what? Frequency 50 Hertz only. Let the velocity is what? 3 into 10 raised to power 8 meter per second. For electromagnetic waves also the speed is what? Nearly equal to the speed of the light. 3 into 10 raised to power 8 meter per second. Can you calculate the wavelength? Lambda. 3 into 10 raised to power 8 divided by what? 50. Lambda is equal to V by F. So normally what is the supply at 50 Hertz? Tell me what is the frequency here? 300 into 10 raised to power 6 divided by 50. You will get 6 into 10 to the power 6 meter. What is the wavelength? 6 into 10 to the power 6 meter means 6000 kilometer. 6000 kilometer guys. So very high what wavelength. So what is the rate of change of the phase? Very low, very slow. Slow hai. The rate of change of the phase very low. Right? And because of this reason, you can represent the complete circuit. We are representing all the electrical circuits we are using. For example, lights in AC and other things. Just we are representing in terms of what? Resistor, inductor, and what? Capacitor. They all are separable. You can say R, you can remove it. Inductor, Henry, capacitor, Farad. You can represent like this: resistor, inductor, and what? Capacitor. They all are separable. These are called lumped parameters. These are called lumped parameters. So in a normal frequency, for example, in frequency 50 Hertz up to what? 20 in range of kilohertz, we can represent like that. So this is called what? Lumped parameters. And this is the circuit theory. So network or circuit theory dealt with what? Low frequency. So we are dealing with the network. So network is what? Circuit theory, or circuit theory we are dealing with the low frequency signal. This is clear. So lumped parameter means we are dealing with the resistor, we are dealing with the inductor, we are dealing with the capacitor, resonance circuit. Sab jagah we are separating the resistor, inductor, we are finding the series connection, parallel connection, voltage division, current division. So they all are separable. But at the same time, if the frequency is very high, for example, in the range of what? Like this is the megahertz, 300 megahertz, or you can say it is a 300 gigahertz, very high frequency, megahertz to range of gigahertz. Then what is the wavelength? Three hundred into 10 raised to power 9, guys. 300 gigahertz, right? So then wavelength will become very low, right? Very low. And what about the rate of change of the phase? Very high. And when the rate of change of phase is very high, then it is not possible to represent the circuit by using what? Lumped parameters. Practically not possible. Then we are representing it by what? Distributed parameters. For example, in transmission line, the frequency, the range is what? In the megahertz. For example, just give easy calculation I am giving, that it is at 300 megahertz. Then it will become 300 into 10 to the power 6. Then lambda will become 1 only, 1 meter. 1 meter only. Very small, frequency is very high, omega is very high, lambda is small. Then distributed parameters like this. And so on. So what is the unit here? Ohm per meter, Henry per meter, Farad per meter, conductance is Siemens per meter, or mho per meter, and so on. So these are called what? Distributed. So here EMFT, electromagnetic field theory. We are using the field theory here. EMFT, field theory. So this is for high frequency, or circuit theory is for what? Low frequency. So today we are dealing with what? We are dealing with what? Circuit theory, not the field theory. Okay, I think this is clear to you. So that is the basic difference between what? Lumped parameter and distributed parameter, and that is the basic reason why, because the frequency is very high, rate of change of phase is very high. The elements which are separated physically are known as lumped parameters: resistor, inductor, capacitor. Distributed elements are those which are not separable for analytical purpose. Transmission line which has distributed resistance, inductance and capacitance along its length. Okay. Then next is, so this is the classification. Now I am going to deal with what? Resistor, guys. First, resistors. Okay. Then what is resistors? Up to this point everything is fine, clear, no doubt. Okay. So straightforward, you will get some theoretical question or what numerical, no problem, but calculator is not allowed. Very conceptual questions are there in ISRO examination. So please, what is the classification? Why we are using this type of questions? So resistors use circuit elements to model the current resisting behavior of the material. जैसे क्या होता है? What is the resistance? It will oppose the flow of what? Current. Simple, in a simple language, it will oppose the flow of current, right? Summarize the lumped and distributed parameters. Okay, Karthik. Lumped and distributed parameter means one minute. Lumped parameters, first point, when frequency is low, omega is low, lambda is high, then we are using the lumped parameters. Lumped parameters. Right? Tell me. Now I want to ask one question, everyone. Right? What about the lambda if it is 10 meter? Tell me. It is high or low? It is high or low? What about the lambda if it is 10 meter? It is a high or low? और जल्दी बोलो. Is it a high value or a low value? Low value. Okay. Everyone, array, all the participants, low or high? Or sir, I have no idea. So please participate in poll. Nota, you are giving a vote. Option A, party 1, party 2, party 3, or at the end, nota. You heard about this? So please participate in poll. All are more than what, 18 years. You have attended the 18 years age. So always participate in poll. Okay. So low. Okay. Tell me guys, what about this line? It is a high or low? What about this line? High or low? It is a bigger one or a smaller one? So we can't say whether it is a bigger one or a smaller one. It is a line. It is a comparative term. It is a comparative term. Now tell me. This is the line number 1. This is the line number 2. Now which one is the bigger one or which one is the smaller one? Then you can say the 1 is the less than what, 2. 1 is the smaller than the 2. But here again the third line, it is the 3. Now we can say 1 is bigger than what, 3. 1 is bigger than 3. Are you getting my point? Comparative term. It is a comparative terms. So it is a comparative term. So for example, lambda, when I am saying that lambda is what, 10 meter, so how we can say? So lambda means what? For example, your tube light. What is the length of what tube lights or LED and so on? We are getting what it is a. This is of what, 1 meter. This is of 1 meter tube light length or any electrical devices. Suppose this is the length of that tube light and so on. Any electrical devices, this is the length in a centimeter or in meter. We are dealing with what, like supply here, 50 hertz supply. So 50 hertz supply, what was the wavelength? 6,000 kilometer. So guys, tell me, as compared to the size of the equipment, what about the lambda? Size of the equipment, what about the lambda? Very large. So we can represent this type of circuit where the lambda is very large with the help of what? Resistor, inductor or capacitor. Because when we are passing the signal through it, there will be a negligible change in phase. Right? Suppose we are passing the signal. So signal will pass through this. So what is the path traveled? Only 1 meter. But what is the lambda? Very large. There is no phase change. Negligible phase change. And that's why we are using what? Lumped parameters for this type of devices. This is clear to you? Now suppose your mobile, the size of your mobile is in what, centimeters, or we are using the signal in the range of what, microwave, or that wavelength it is in the range of what, millimeter, or in the range of what, micrometer. So that range is what, very low. So lambda is very low as compared to size of the component. Are you getting my point, everyone? Lambda is very low as compared to size of the component. In that case, that particular device, for example, this is the size of the component, that it is a 1 centimeter, the length is 1 centimeter, or lambda is 1 micrometer. So when the lambda is 1 micrometer, very small, we are passing the signal. When the signal will pass from this point to this point in 1 centimeter, it will cover 10 to the power 4 cycles. 10 to the power 4 cycles. There is a huge change in phase. So you can't represent it by what lumped parameters. You have to use the distributed parameters. Okay, very simple. No need to enter into the depth of that. No need to do the PhD or MTech. Simple. Distributed parameter and lumped parameters. So when the lambda is very high as compared to size of the component, lumped parameters. When the lambda is very low as compared to size of the component, distributed parameters. Okay. Conclusion. Final. Or remember guys, so I think again second question interview. What about this high or low? So remember in interview they will ask, what about this value? 10 microvolt. High or low? Sir, low value. No. Always say what comparative term. Sir, comparison में. तो ये भी interview के लिए. Okay then. Now register. So register means quickly get the answer. Register. This is a register. Then one minute. Okay. Now this is the cross sectional area. This is the length of the bar. The simple formula for the resistance is rho L by A. Rho is called the resistivity of that bar, L is the length of that bar, A is the area of cross section, or this is called 1 by sigma L by A. This is the resistance. The unit of the resistance is what? Ohm. Okay. Then we are getting the question on this, na? Conductivity or what resistivity. So this is the conductivity and this is the resistivity. Sigma is called conductivity of the material. And the reciprocal of that is called what? Resistivity. L is the length of the bar, A is the cross section, and this is the symbol for the resistor. Okay, symbol for the resistor. And then if we are applying the voltage V, there will be the current I. So I is proportional to V, and then the constant of proportionality is what? 1 by R. That is the slope is what? 1 by R. It will follow the Ohm's law. It is a linear element. It will follow the Ohm's law. That is the V by R. Okay. So this is a resistor. So we have idea about that resistor. Now it is directly, remember, but it is a directly proportional to length. We are increasing the length, resistor will increase. It is inversely proportional to area. We are increasing the area, resistance will decrease. Right? Resistance will decrease. Now series connection. If the resistors are connected in series, so what is the R equivalent? R1 plus R2 plus what? R3. This is what? Series connection. When resistors are connected in parallel, this is the parallel connection. So what is the R equivalent? If you want to calculate the R equivalent, then 1 by R equivalent is equal to 1 by R1, 1 by R2, and what, 1 by R3. This is the parallel connections. Now if the two resistors are connected in parallel, this is R1, this is R2, for example. So this is R equivalent will become 1 by R equivalent is equal to 1 by R1 plus 1 by R2, and that is R1 R2 upon, this is the R1 plus R2. So what is the R equivalent? R1 R2 upon R1 plus R2. R1 plus R2. That is the general formula for two resistors in parallel. R1 R2 upon R1 plus R2. Then remember, when we are connecting the resistor in series, the value of resistance will increase. For example, in series connection, suppose I am choosing the R1 is equal to 10, R2 is equal to 20, R3 is equal to 30. So R equivalent will become 10 plus 20, 30, 30, 60 ohm. Means the equivalent will be more than the highest value. Are you getting my point? R equivalent will be more than the highest value, larger than the largest value here. Okay, R equivalent. So which means when we are connecting the resistor in series, we are increasing the value of the resistance. This is the resistance increases. When we are connecting the resistor in parallel, then guys tell me, what about the value, decreases or increases? For example, I am connecting 10 ohm resistor and 40 ohm resistor in parallel. So 10 ohm and 40 ohm are connected in parallel. So what is the R equivalent? 10 into 40 upon what? 10 plus 40. So this is nothing but 400 by 50, 8 ohm. So what about the value of the resistance? It decreases and it is less than the lowest value. It is less than the lowest value. So R equivalent is less than the lower value. Okay, so when the 10 and 40 are connected, it is less than what? 10 ohm. So directly you can say, okay, it is a 8 ohm value. So when the resistors are connected in parallel, the value of the resistance will decrease. Okay, so this is the R equivalent. Is there is any doubt? Is there is any doubt in this? Now, so tell me, if the two resistors (800 ohm and 200 ohm are connected in parallel, what is the equivalent? What is the equivalent of that? 800 ohm and 200 ohm are connected in parallel. (800 ohm and 200 ohm are connected in parallel, then what is the equivalent of this? अरे आप अभी रुक जाओ, it is a important topic. Some student will leave the class. Okay sir, I have learned about this in 12th class, 11th class. You are just wasting our time. है ना? Yes or no? And what is the parallel combination of 8 and 2? Okay, so that is what 1.6. For example, parallel combination of 8 and 2 is what? 8 into 2 divided by what? 8 plus 2. It is a 1.6 ohm. Now guys, when I want to calculate the parallel combination of 8 and 20, so it is a 16. So what we are doing actually, we are calculating 80 into 20, then we are doing the 80 plus 20, where that is a 1600 divided by what, 100, and we are getting the answer 16. Okay, but what we can do, 80 and 20, what is the common here? What is the common? Most common, this is the highest common factor, HCF. You can calculate the HCF. 20 or 80 highest common factor, you can take 10 or you can take 20. Like the 20 is common. Now the parallel combination of 4 and 1. Right, 5, 4, you will get the answer 16. Or you can take the common factor 10. Now it will become 8, it will become 2. 8 into 2 divided by 8 plus 2. So what is the answer here? 16. So for example, in 800 and 200, you can take the common factor 200 or you can take the common factor what? 100. For example, 100 is common. Then what is the parallel combination of 8 and 2? 8 into 2 plus 8 plus 2. So it will become what? 16. 160 directly. So 800, 200 is equivalent to what? 8 and 2, but it is multiplied with what? 100 only. I think it is clear to you. So just keep the common factor here. So calculation will become easy. Calculation will become easy, guys. For example, 800, you can also take 200 common, then it will become 4, it will become 1. 4 divided by 5 multiplied with the 100. So again you will get the same answer, 160 ohm. So this is the parallel combination. So this is the resistor. So resistor merely what? Dissipate the energy. It can't store the energy. Dissipate the energy means, for example, it is a resistor. We are giving any voltage V. There will be the current I, R. So what is the current? V by R. Then the power dissipated across the resistor is I square R. Or we can write the I is equal to V by R. What is the power dissipated across the resistor? V square by R. V square by R. So we can calculate I square R or we can calculate the V square by R. So this is the power dissipated, not stored. Energy, it can't store the energy. Only the power dissipation in the form of what? Heat, or in the form of light, or in other form. Here it is dissipated. It can't store the energy. Here resistor. Power, okay, and that is given by I square R or V square by R. Simple. Resistor. चलिए बताइए, what is the answer? What is the answer for this question? अब ये थोड़ा क्विकली बनाना है ना, पैरेलल सीरीज कॉम्बिनेशन. Find the R equivalent of the given circuit. अरे स्टार्टिंग 2 to 3 क्लास तो इजी है यार, मतलब ज्यादा कुछ नहीं है. बस उसके बाद ये अपना लेवल पकड़ेगा तब पढ़ेंगे बहुत अच्छे से एक एक चीज. अभी तो बेसिक रजिस्टर, इंडक्टर, कैपेसिटर 12th क्लास का है ये. ऑल आर एंजॉयिंग द सेशन, यस और नो? अरे लेकिन अभी तो जस्ट स्टार्ट है, फर्स्ट सेकंड क्लास है ये. ओके, जैस 14.4 कार्तिक. भाई प्लीज ट्राई टू गिव द आंसर. इट इज अ वेरी इजी क्वेश्चन. एवरीवन पार्टिसिपेट, कैलकुलेट द वैल्यू. Yeah, we are getting this type of question. Calculate the equivalent resistor. Okay, 14.4. बाकी लोग है ही नहीं लगता, प्रेजेंट ही है कि नहीं पता नहीं यहाँ पर. एक ऑनलाइन का ना ड्रॉबैक है. ऑनलाइन वी हैव द ड्रॉबैक दैट स्टूडेंट्स आर नॉट विजिबल. लेकिन यहाँ तो जूम क्लासेस अभी एक बार कैमरा ऑन करवाएंगे बाद में कि यू आर प्रेजेंट यस और नो. ओके, बी अलर्ट, टेबल में बैठिएगा भाई. और कॉपी पेन कैलकुलेटर, आज इंस्ट्रक्शन दिया नहीं हूं मैं. ओके, इजी ना. देखो, these are new students, these two are in series, so 5 plus 1 6. First of all calculate, these two are in parallel, 6 and 3. 6 parallel with 3 means 6 into 3 upon 6 plus 3. Remember, not this result you have to remember, that is the 2 ohm. 6 and 3 are in parallel, that is the 2 ohm, less than what, 3. Now so normally what we are doing, actually we are missing this register. There may be the chance of what, calculation mistake, and that's why be careful about this register. Normally we are missing this register. Then 6, this is what, 2, this is 2, this is 4, this is 8, this is 4 and 6 are in parallel. When the 4 and 6 are in parallel, 24 divided by 10, that is the 2.4. So this resistor is 2.4, this is 4, this is 8. These three are in series. This is 4, this is 8, and that is what, 2.4. These are in series. So 8 plus 4, 12, 2.4, 14.4. बिल्कुल सही आंसर. 14.4 is the answer. And from this 14.4 ohm is the answer for this question. Easy question. Now tell me, determine the equivalent resistor RAB in the circuit shown in the figure. Now guys, this 5 and 1 are in series, that is the 6 and 4, that is parallel. So 6 parallel with the 4, it is 6 into 4 upon 6 plus 4. Right? तो यही है ना. एक मिनट रुकना जरा. यस. नाउ फर्स्ट ऑफ ऑल, सॉरी, उसको भी है और उसको भी कर सकते हो और इधर भी देख सकते हो. इजी बनाना है तो फर्स्ट ये देखो, लाइन देखो. दिस पॉइंट इज शॉर्ट सर्किटेड. तो दिस पॉइंट इज शॉर्ट सर्किटेड मींस दिस 12 ohm resistor is in parallel with the 4 ohm. Is it clear? 12 ohm resistor is in parallel with the 4 ohm because B and B, this is the D and C, right? So ये B and D are the same node. This is B and B, this is are the same node. So you can shift here, and that's why you can redraw it. Now this resistor is connected here. This is the 12 ohm and this resistor is connected here. This is the 6 ohm. Now this 6 ohm is connected parallel to this. This 12 is connected to parallel to this 4. Now the calculation will become very easy. What is the parallel combination of 12 and 4? This is the 3 ohm. 12 into 4, remember that, 12 plus 4. That is the 3 ohm. Now this 3 ohm is in parallel with the 6 ohm. So no need to calculate this. No need to calculate this. 6 parallel with the 3, we have idea 2 ohm. So up to this point 12 4 in parallel, and this is the up to this point 2 ohm. 2 plus 1, 2 plus 1. Up to this point it is a 2 ohm. 2 plus 1 3. Now what is the parallel combination of 6 and 3? 2 ohm. So you can only focus on this. So you can redraw it. So up to this is the 2 ohm, 6 parallel with the 3 2 ohm, or this is the 2 plus 1 3 ohm. and this is the 10. What is the parallel combination of 3 and 2? 3 into 2 upon 3 plus 2, that is nothing but 6 by 5, 1.2 ohm. What is the R equivalent? 10 plus 1.2, that is 11.2 ohm. 11.2 ohm. Shobham, it is clear. Harshita, Adinath, your answer is correct. Okay. I think now it is clear to you. So, first of all, watch the circuit carefully. It is a short circuited node to same node. That's why you can change the position. Then the question will become very, very easy. You are going to start from that, then it will become very lengthy. But otherwise, this question is what? Very, very easy. How to find the R equivalent. I think now it is clear to you. Yes, this is the 10 ohm. Bilkul correct hai, 10 ohm. So the very, very easy question. 3 plus 5 plus 4, that is what? 12 parallel with the 4. 12 parallel with the 4. Remember, it is a 3 ohm. 3 plus 3, 6. 6 parallel with the 6. 3 ohm. 4 plus 3, 7 plus 3, 10 ohm. Is there any need to solve? 10 ohm. So these three are in series. This is in parallel. First of all, find up to this point. Then find up to this point. Okay. Up to this point, 12. 12 parallel with 4, 3 ohm. 3 plus 3, this is a 6 ohm. 6 parallel with the 6 up to this point, it is a 3 ohm. Not the same diagram, and that is finally you can write the 10 ohm. Okay. So this type of questions. Now give me 1 minute. There is a one assignment for you. Two resistors of values 2 ohm and 4 ohm made of different materials with a temperature coefficient of resistance 3 ppm per degree centigrade and 6 ppm per degree centigrade respectively are connected in a series. What is the temperature coefficient of resistance of net resistance? So yes, there is a variation in what value of the resistance, right? Variation in the value of the resistance with what temperature. When temperature increases, resistance increases. Temperature increases, resistance increases. So what we are doing actually at any particular temperature, this is given by R at a T, 1 plus alpha T1 minus T. This is the change in the temperature multiplied with the alpha, and this is the resistor at T temperature, resistor at T1 temperature. So this is the given by this, and this alpha is called what? Coefficient. So this is the value. Respectively are connected in a series. What is the temperature coefficient of resistance of the net resistance? So if the two resistors are connected in series, guys. So this is the R1, this is the R2. Coefficient is alpha 1, coefficient is alpha 2. Okay. Now, if it is increased by alpha 1, it is increased by alpha 2. So what is the new value of R1 and what is the new value of R2? Then what is the overall change and what is the coefficient of that equivalent? Equivalent resistor will become R1 plus R2. If there is no change, then the equivalent resistor will become R1 plus R2. But if there is a change, so just I am giving you the assignment, I can directly write the formula also, but you have to verify it. So tell me 1 minute. For example, I am giving you the answer. Now, this is the case that if the alpha is the value, if there is a change in the temperature, then change in the temperature means the value of the resistance will change. What is the new value of R1 will become? alpha 1 del T. This is the change in the temperature. What is the new value of the R2 will become? Del T. So what is the new total value? You can add these two, you will get the answer R1 plus R2 plus R1 alpha 1 T plus R2 alpha 2 del T. So guys, what is the change here? The change is for when we are connecting directly R1 plus R2. When we are increasing the temperature, so what is the change in the value of the resistor in R equivalent? You can say what is the change? R1 alpha 1 plus R2 alpha 2 into del T. This is the change in the resistors. Are you getting my point? What is the change? This total new value minus R1 plus R2, that is the change in R equivalent. R1 alpha 1 plus R2 alpha 2 del T. So what is the per unit change? Per unit degree. So you can say R1 alpha 1 plus R2 alpha 2 divided by del T. So this is the per degree centigrade. Now what is the coefficient? Coefficient means with respect to that value. So you have to divide it by what? R1 plus R2 plus. You have to divide it by what? R1 plus R2. Then when we want to calculate what is the alpha of the overall. So alpha of the overall is given by R1 alpha 1 plus R2 alpha 2 upon what? R1 plus R2. R1 plus R2. So this is the formula. You have to use this formula because that quantity, the change is divided by the temperature del T and divided by what? Overall value R equivalent. R1 plus R2. So that is the per unit change. R1 plus alpha, R1 alpha 1 plus R2 alpha 2 upon R1 plus R2. So what is the answer here? What is the answer here according to this formula? A. You are getting the A? A is the answer. Okay. So simply this is the change 3 multiplied with the 2, 4 multiplied with the 6 upon 2 plus 4. Finish. This is the question from the ISRO examination. 2 into 3 plus 6 into 4 upon 2 plus 4. 30 divided by 6, that is the 5. Easy? Okay. तो assignment क्या है? This is for series connection. You have to find for what? Parallel connection. So this is the question on series connection. Now find for what? Parallel connection. If these two are connected in parallel, then what is the overall coefficient? Right? Find it. Then. So there are different types of questions, guys. I am giving you the assignment, but once we will get the idea about what voltage sources, KCL, KVL, then we will solve. But this is the assignment. Just I want to check. So this is the question again from the ISRO examination for a network shown in the figure. Calculate the current I2. Just to calculate the current, sometimes we have to calculate the R equivalent, or we have to use the KCL, KVL, mesh analysis, nodal analysis. In next two classes, we will discuss what? Voltage and series connection, right? Or what? Voltage source, current source, series connection, parallel connection, voltage division, current division rule, mesh analysis, nodal analysis. Then you can solve this type of questions. So try to solve this type. Okay, mic is it audible? Sorry, mic निकालिएगा. 1 minute. Okay. Now, so guys, this type of questions we will solve. For example, in this case, we can use the source transformation. You can use the current sources converted into voltage. You can apply the nodal analysis, or you can apply the mesh analysis to calculate the current I2. You have to find the current I2 at this point. Okay. So there are different ways to solve this type of questions. Suppose that one resistor is connected parallel to the 4-volt source. So what will happen? The next class we will discuss. So ये assignment है. Try to solve this question. You will get the bonus marks. Are you getting my point? I have not covered this topic, but you are solving the question means you are getting the bonus marks. So simply in ISRO examination, suppose you are attending the particular coaching, but you are getting any extra question that is not covered by the any faculty members, but you are able to solve those questions, then you will get the extra bonus marks, and definitely you will be selected, because normally the student will solve right from their notes or from their coaching notes and so on. तो ये बोनस मार्क्स है, अगर आप सॉल्व कीजिए, ट्राई कीजिए, फिर तो मैं तो कवर करूंगा इसको. तो दिस टाइप ऑफ क्वेश्चंस वी आर गेटिंग राइट नाउ. Now this one is the for inductor. Inductor and resistor, we are using the same rule. We are using the same rule for inductor, same rule for what? Capacitor, resistor. Suppose the two inductors are connected in series, we are getting the same answer. It is L1, it is L2. So what is the series combination? L equivalent is equal to L1 plus L2. In a parallel combination, same rule, just like a resistor. So what is the parallel? L1 L2 upon L1 plus L2. So don't worry about the inductor and capacitor. We will learn more about the inductor and capacitor in case of what transient. But just I want to give you the idea. Series connection and parallel connection. So in series connection, inductor is just like what? Resistor. Inductor just like a resistor. So just like resistor means series connection and what? Parallel connection. For example, just I am going to replace it by what? Resistor. Like this is the value of the resistor is L. What is the equivalent resistor across AB? Same procedure for inductor. So what is the value of the inductor at this point? At AB. 5L by 2, 5L by 8, 3L by 2, 3L by 8. Or there may be the resistor also, same type of. Remember, in case of inductor, series combination, same formula. If the two inductors are connected in series, overall value of the inductor will increase. If the two inductors are connected in parallel, overall value of the inductance will decrease. Unit of the inductor is Henry. Unit of the inductor is Henry. Tell me what is the answer? 5L by 6. Okay, you have to solve within 1 minute. No, okay, no problem. 5L by 6. So 5L by 6 is it is in answer. 5L by 2 is 5L by 8 is it is in answer. 5L by 6 is not in answer. You are saying that all are to marks to all. MTA हो गया तो question marks to all. According to you. Okay. Now, always watch this type of question. Now, always watch the node. Node means 5L by 6. Again, you are giving the 5L by 8. Okay. One student is giving 5L by 8. Priyus, Paul, na? Okay. एक मिनट. Your name is not visible to you. Priyasa Paul. Okay. देखो. This is what, this is the node. Always watch the node. This is the A node. This is also A node because it is a short circuited. This is also the A node. Right. These all are same node. Similarly, this is B node. This is B node. This is B node. Right. Now here, like this is the C node. It is the D. Now the question will become very, very easy, guys. We have to find the across A and B. So right. This is the A. This is the B here. In between we are having the C and D here. Now, from A to C, how many inductor? 3 inductor. A to C there are 3 inductor, 1, 2 and 3. From B to D how many inductors? Same symmetrical device, 3. Three inductor, L. From C to D, how many inductor? 1 inductor from C to D. Right? Now we have one more inductor because 1, 2, 3, 6, 7. There is a one more inductor 8 L between A and B. We can connect here A and B. This is A, this is B, and this is the inductor. Right? Quickly you can observe the circuit. Now these 3 inductor are in parallel, just like resistor. The inductor value of the inductor will reduce. So it will become L by 3. This is L and this is again L by 3. And now there is a one inductor in parallel, that is L, just like resistor. Now it is connected in series. So what is the parallel combination? L plus L by 3 plus L by 3. So 3 plus 4 plus 5, 5 L by 3. This is the 5 L by, am I correct? 5 L by 3. This is L, this is 5 L by 3. These two are in parallel. You can take the L common, already I have said now. Common factor L, 1 into 5 by 3 plus 1 plus 5 by 3. So 3 cancel, it will become 5 L by what? 8. 5 L by 8. Is it clear, guys? This is clear to you? You can take the L as a common, and then 1 and 5 by 3 are in parallel. 5 by 3 multiplied, here it is a 5 L by 8. Very simple question. Or in place of inductor you can put the resistor. You will get the same answer. 5 by 8 R. L by 8. Okay. Then so what about the capacitor, guys? What about the capacitors? We are using the same formula for capacitor? No. Like this. Capacitor opposite to what? Resistor. Capacitor is opposite to what? Resistor. When the two capacitors are connected in parallel or connected in series, for example. So what is the C1 C2 by C1 plus C2? Less than the lowest value. So when the capacitors are connected in series, the value of the capacitor will reduce. Right? Opposite to what? Resistor. Or when the capacitors are connected in parallel, the value of the capacitor will increase. C1 plus C2. So in parallel we have to add the capacitors, in series we have to reduce the value of the capacitor like this. So when the two capacitors are in series, then the equivalent is C1 C2 upon C1 plus C2. The value will reduce. Okay. Now tell me, what is the answer for this question? Last one. Then I will give you the 1 or 2 assignments. Tomorrow I will give the answer for all your assignments question. No? Tell me, what is the answer? I think I have given one question. No? Tell me, guys, what is the answer? आपका आंसर क्या? What was the power delivered at 3 millisecond? आपका आंसर क्या है? $20. Here you are taking the 20 microfarad. Okay. So yesterday I have given you the one assignment. What was your answer? Remember, guys. Normally we are doing the silly mistakes, but remember here. These 5 and 20 are in series, but it is not resistor, it is capacitor. So 20 and 5 are in series. So 20 into 5 upon 20 plus 5. So that is the 4 microfarad. So this is the 4 microfarad. Up to this point it is the 4 microfarad. This 4 microfarad and 6 microfarad in parallel. 4 microfarad and 6 microfarad in parallel. That's why up to this point it is the 10 microfarad. In parallel we have to add the capacitor. 10 microfarad. 4 plus 6, 10. 10 plus 20, this is the 30 microfarad. 30 microfarad. 10 and 20 are in parallel. So up to this point 30 microfarad. Now the 30 and 60 are in series. Or 30 and 60 are in series. So what is the common here? 10 is common. 6 into 3 upon 6 plus 3. 10 into 2, that is the 20 microfarad. 20 microfarad. And that is the correct answer, 20 microfarad. So what about the other student? Is there any doubt? Is it clear? Series connection opposite to resistor. No need to add here. 4 microfarad reduces, parallel increases, series reduces, and you will get the 20 microfarad. Okay, 20 microfarad. Then just I am giving you the two assignments. Everyone try to solve this question. This is the first one. Okay, this is the first one. Then 50, 70, 20, 60, 120. Very easy question. This is the assignment. हो जाएगा, बन जाएगा. I will solve at the exam time. No need to solve. No. अरे इजी हो चाहे हार्ड हो, प्रैक्टिस करो. आंसर सही आ रहा है या नहीं आ रहा है. यू कैन अवॉइड द सिली मिस्टेक्स गाइस. सिली मिस्टेक्स बहुत होती है एग्जाम में. बनाना है सबको. मैं आपकी कॉपी चेक करूंगा. तो ये भी हो गया असाइनमेंट. और ये आपका एक और देता हूं मैं आपको क्वेश्चन, ये वाला. यहां पे फाइंड करना व्हाट इज द इन द गिवन फिगर द इक्विवेलेंट कैपेसिटेंस बिटवीन टर्मिनल ए एंड बी. A and B, you have to find the equivalent capacitor. A and B. Okay. Now the answer for the last assignment. We will solve more and more question, guys. Don't worry. Then answer for the last assignment was, I think it is this was the question. No? Question I is equal to 5 cos of 60 pi t. I is equal to 5 cos of 60 pi t ampere, and V is equal to A option 3I, and B is equal to 3 di by dt. It is in ampere. It is in volt. You have to calculate the power. So in first case, the power at 3 millisecond was 53.48. At a 3 millisecond. Are you getting this answer? At 3 millisecond, 53.48 watt. Good. Yeah, 53.48. And for second question, P is equal to minus 6.396 kilowatt. Minus 6.396 kilowatt. This is the answer for this one. First of all, differentiate it. Then power calculation means V into I. Already I have given. Then put the value, the 3 millisecond. Right, and then you can use the virtual calculator also, and then you can find the answer. So we are getting the negative value. If suppose we are getting the negative value, means it is what? Delivered. Or positive value means what? It is absorbed. Negative value means it will deliver the power towards the source. If it is positive value means it will absorb the power. It depends upon the phase of the current and voltage. Okay. So this is the answer. So how many students are getting this answer? One student have given the answer. Sobna. Okay. 53.48. Good. What about the other? So ये answer. अब now try to solve that question. and already I have given the 3 assignments, so try to solve those questions, guys. Then thank you, guys. Hope you are enjoying the session. Yes or no? Tell me. Okay, this is a second class and ask your friends to join the session. Try. अरे यार कैसे बोलोगे, ऑफलाइन नहीं है. If you are in touch with the other students, then ask them to join the live sessions. Okay, and try to attend the regular live sessions, and you can ask any type of questions related to the subject, related to the notes. I will upload the notes. If you find any difficulty, any calculation mistake, please inform me. Okay. Two sources are connected. Now, I will cover that topic in voltage and current sources tomorrow. When we are covering voltage and current sources, when the two voltage sources are connected in parallel, connected in series, one voltage source and one current source are connected in parallel, then what will happen? Okay, yesterday I will cover that topic. Okay, then thank you very much. Have a nice day. Revise it. Make your own notes also. Make your own notes also. Formula notes, at least formula notes and short notes. ओके तो वो क्या है, आपकी ड्यूरिंग एग्जाम आपकी हेल्प करेगा कि आपको कैसे क्विक रिवीजन करना है. ये हमारे नोट्स है. डेफिनेटली आई विल अपलोड द पीडीएफ, लेकिन आपके पास एक कॉपी है, यस और नो? 200 पेजेस कॉपी, ब्लैंक कॉपी. तो आपको अपने शॉर्ट नोट्स बनाने हैं, फॉर्मूला नोट्स बनाने हैं. डेली आप कम से कम 2-4 पेज लिखिएगा जितना आपने पढ़ा है, और वो पीडीएफ को साइड कर दो, वो डिजिटल लाइब्रेरी में डाल दो, उससे रिवीजन नहीं हो पाएगा. ओके देन, थैंक यू.